Assalamualaikum warahmatullahi wabarakatuh. Sa lesson 5 class, ito yung last topic natin sa midterm coverage, the applications of integrals. So in application of integrals class, we have the area of the surface of revolution, the center of mass of a plane region, the center of mass of a solid of revolution, and lastly, the first theorem of Pappus. So first, we will talk about the area of the surface of revolution. Let C be an arc in the xy plane and let L be a line which may intersect C only at end point. When the arc C is revolved about the line L, the surface of revolution is generated. So if ito yung figure natin sa 5.1, ito yung line L natin or the ito yung, dito nag-revolve yung arc C natin. Ibig sabihin, this is the axis of revolution. And then, ito naman, itong figure na to class is this is our arc C. If ipaikot natin to dito sa line L class, yung surface of revolution natin is nag-generate. Ibig sabihin nun, let's say for example, may bottle tayo, tapos, lagyan natin ng stick sa loob. Okay? And then, let's say yung bottle na yun is ipaikot natin doon sa stick na yun, which means yung bottle na yun class is an example of an arc C. Tapos, yung stick na yun is an example of the line L, which means yun yung axis of revolution or doon natin pinaikot yung arc C natin. So, which means, may mabubuo tayo or yung surface of revolution natin is nag-generate, which means may mabubuo tayo doon na surface of revolution. We will refer to the area of this surface as lateral surface area, and then this line L naman class is called the axis of revolution. Let us consider some special cases. For the case 1 class, when C is a straight line segment rather, and L is a line that touches the arc C at one end point only. The resulting surface of revolution is a right circular cone. So, if dito tayo sa figure 5.2 natin class, if etong line na to class is the arc C, which is the straight line segment, tapos let's say dito yung isang endpoint niya, tapos etong dashed line dito that is our line L. Okay, so if etong one endpoint of the arc C natin is mag-touch dito, tapos i-generate natin dyan, or ipaikot natin dito sa line L na to, ang mabubuo natin na surface of revolution is a right circular cone. Okay, so ito yung mabubuo natin dito na surface of revolution. So if the other endpoint of the line segment is r units from the axis of revolution, okay, let's say ito yung axis of revolution natin, etong line L, and then papunta natin dito sa line one endpoint ng line segment natin. So this is r units from the axis of revolution, and the length of the line segment is L. Then the lateral surface area is of the right circular cone is equal to pi, S equals to pi RL. Okay, pi RL. Kasi di ba ito class is 2 pi R, tapos ito yung line L natin, or yan yung arc natin. Tapos we have 2 pi R over L. So that's why ang lateral surface area ng right circular cone natin is S equal to pi RL. We may intuitively justify this formula by cutting the cone along a generator. So that is along L, yung arc natin na straight line segment, to obtain a circular sector with radius L, arc length 2 pi R, and central angle 2 pi R over L in radians. So ang magiging lateral surface area natin is S equals to 1/2 times central angle in radians multiplied by the radius squared. So magiging, substitute natin yung 1/2, replace central angle in radians by 2 pi R over L galing dito. And then yung radius natin is that is equal to L, so squared. So we obtain pi RL. In case 2 class, when C is a straight line segment and L is a line that does not touch either and point of C, the resulting surface is a frustum of a cone. Okay, so see figure 5.3. So let the smaller radius, itong maliliit na radius dito, dr sub 1, and the larger radius yung sa baba, sa bottom ng circular cone natin, r sub 2, and the slant line L, okay, here, and then height, and the slant height L, okay. The lateral surface area S sub F of a frustum of cone, kasi pag pinutol natin to class, di ba pag tinanggal natin to, ang mabubuo natin, di ba, cubic lambo, no? Naya form yan class na frustum of a cone. The lateral surface of a SF or the frustum of a cone is the lateral area of the big cone. So, di ba, kung ito yung smaller cone, ito na yung matitira na frustum of a cone. Ibig sabihin, ito yung big cone. Okay. Less than the area of the cone at the top. So, ang mangyayari is S is equal to pi times R sub 2. Okay. Times L plus L sub 1. Kasi di ba si R sub 2 is magiging L plus L sub 1 minus yung sa taas, yung smaller cone. We now state the formulas for the lateral surface area of a surface of revolution. So, summarize natin dito yung mga formulas na magagamit natin for the lateral surface area of a surface of revolution. So, first is when C is given by y equals to f of x, where x is between a to b, and C is revolved about the x-axis. Kung ang arc C natin class is revolved about the x-axis, then the area of the surface of revolution is given by a of s equals to 2 pi. Okay, constant na yung 2 pi ha, times the integral of f of x, yung function natin na given, okay, times the square root of 1 plus f prime of x quantity squared. Ito yung length ng arc natin, dx, evaluated from a to b, or this is just equal to this form. So, pwedeng ito na yung gamitin natin na formula. Ihahanapin natin yung area ng surface of revolution if ang given na yung function natin na f of x, and then it is revolved about the x-axis. So, ito yung formula na gagamitin if it is revolved about the x-axis. When C is given by the parametric equations, x equals to x of t, ibig sabihin dalawa involved dito kasi parametric equation x in terms of x in terms of t, and y in terms of t. Y equals to y of t, where x is between a to b. Then the formula for the area of surface of revolution is given by the formula. Okay, ibarat bukman no parametric equation na given, tapos pangiluban nyo sa area of a surface of revolution, nagipag-usar nyo sa formula number 2. Kung so dito given you class na it is if yung arc is revolved about the x-axis, ipag-usar nyo formula A sa number 2. If C is revolved about the y-axis naman, ito yung gagamitin nyo na formula. Formula 2, letter B. Remark the formula for the lateral surface of area of a surface obtained by revolution about the x-axis may be written as, so ibig sabihin gaya, the same bu saya. Okay, kapakaya giusar nyo. A of s is equal to 2 pi times the integral of y. Okay, gaya kasi na equivalent na y, kautos kanyan. So that's why y buaya. And then si ds class, ito yung equivalent niya. Okay. And the formula for the area of a surface obtained by revolution about the y-axis naman may be written as a of s is equal to 2 pi times the integral of x ds. Okay. Kung revolve about the x-axis, yung function natin dito is y. Tapos, kung revolve about the y-axis naman, yung function natin dito is in terms of x. So, parehas pa rin na ds. Yung ds na yan yung length of the arc. First example is find the surface area generated by revolving about the x-axis. Okay, take note, it is revolve about the x-axis. Ibig sabihin, yung gagamitin natin na formula is yung first formula or yung nabanggit doon sa pinakababa. a of s equals to 2 pi times y ds evaluated from a to b. The arc given by y equals to x cubed. So, ibig sabihin, ang i-replace natin dito kay y is si x cubed and then replace a by 0 and then replace b by 2 kasi ito yung given natin na limit. So, refer to this figure. Ito yung figure ng given natin. So, di ba ang sabi is revolving about the x-axis, which means ito yung axis of revolution natin. So, take note class, kailangan yung arc C natin is kailangan hindi, must not touch the axis of revolution. So, ito yung first na gagawin natin para mahanap natin yung area, surface area of revolution or area of a surface of revolution. So, we have y equals to x cubed galing dito sa given natin. And then, get the derivative of this, dy over dx. Okay. Ibig sabihin lang dy over dx is integrating with deriving or differentiating with respect to x. So, dy over dx niya is si y na equivalent yan po si dy dx, dy over dx hindi na y prime. Di ba niya discuss din na yan si sa calculus 1. So, ang derivative ni 3x squared, x cubed class is 3x squared. Kumbaga, ito class is just the derivative of the given function. Tano din nyo na, ayan, derive niyo na so given na arc. Ayan, given tanwa arc na y equals to x cubed. And, si ds, di ba equivalent lang yan as 1 plus the square root of 1 plus dy over dx, quantity squared dx. Okay, equivalent yan. Di ba sa first formula, may mention tayo sa previous slide. So, ayan, bali ds tano na square root of si 1, constant dinanan, always dinanan 1, always dinanan plus. dy over dx sa miya tano na si 3x squared. Ino namin bali 3x squared, ginan so derivative x cubed. Tapos, quantity squared, constant yung pananan. And then, dx. Bakit dx? Kasi in terms of variable x. Okay. So, this is equal to the square root of 1 plus 9x to the 4 because 3 squared is 9. And then, x squared, quantity squared is x to the power of 4. So, ibig sabihin, nag-i-pag-substitute tayo kay ds. Okay, gaya, i-substitute saya na gini. Okay, so thus, a of s is equal to, magiging 2 pi. Okay, si 2 pi class is constant yan. Constant si 2 pi. So, which means, always yan given. Okay, so 2 pi, yan siya, using the formula number 1. And then, replace a by 0, yung sinabi ko kanina. And then, replace p by 2. And then, si y, replace it by x cubed kasi yan yung RC natin. That is the given. Okay. And then, si ds, replace it by the square root of 1 plus 9x to the power of 4 dx. Okay. Galing yan dito. Take note ha, si dy over dx dito, yan yung first derivative ng RC natin. Solving for the integral of x cubed times the square root of 1 plus 9x to the 4 dx by substitution. Okay, yung first technique of integration. Okay, we let u equals to 1 plus 9x to the power of 4 kasi yan yung, di ba yun yung nasa loob ng parenthesis na radical sign natin. So, yan yung ilalat natin na u. And then, derivative natin to, derive natin to both sides. Derivative of u is du. Derivative of this is 36x cubed dx. Or this is just equal to du over 36 equals to x cubed dx. So, which means, si x cubed dx class, okay, eto class, pwede natin siyang ma-rewrite as this form. Inuna kong nilagay sa unahan si square root of 1 plus 9x to the power of 4. Nilagay ko sa huli dito si x cubed, so magiging x cubed dx. Parehas lang yan ha. Okay, eto class, replace it by the square root of u kasi yung nasa loob na yan class or yung index natin radicand rather is, yan yung gilat natin ngayon. So that's why square root of u. And then si x cubed dx plus, replace it by du over 36. Or factor out natin si 1 over 36, we left with the integral of u to the power of 1/2. Transform it into exponential function para mas madali natin siyang ma-integrate, du. So, ang integral nito is u to the power of 3/2 over 3/2 plus c. So, 1 over 36 times 3/2 is, divided by 3/2 is 1 over 54. Balik natin siya into original. Si u, i-replace it by 1 plus 9x to the power of 4. And then u to the power of 3/2 man. So, si 3 dito ilalagay sa exponent. Si 2 is yan yung index plus c. So, therefore, ang area of a surface of revolution natin is magiging ito. Okay, so that is equal to pi over 27 times 145 square root of 145 minus 1 square units. So, always square units sa last. Pag area of a surface of revolution yung hinahanap. Pag area ha, iba din pag volume kasi cubic units. Okay, so ito, simplification lang class. Kindly check if tama ba talaga. Another example class is find the surface area generated by revolving about the y-axis. So, sa previous example natin, it is revolve about the x-axis. So, kung y-axis, which means yung na-mention ko doon sa previous slide na ang formula is a is equal to 2 pi times the integral of x dx. Pag y-axis ha, this is x. Pag x-axis siya nag-revolve, ito is dapat y. The arc is given by y equals to x squared, and then where x is from 0 to 2. So, ito yung gagamitin natin na formula. So, na-discuss ko na ito kanina ha. So, which means, si x dapat yung in terms of x, which means, kailangan yung arc natin is in terms of x din dapat. Okay, so where y equals to x squared, di ba ito yung arc natin? Y is equal to x squared. So, ang derivative ni x squared is 2x. Sabi po pagminsa dy over dx na ganun. So, derivative ba ya? Okay, dy over dx is just equivalent to y prime. Okay, so yung ds natin class, that is equal to the square root of 1 plus dy over dx. Giyan na always saya constant tanan. Okay, 1 plus si dy over dx, replace it by 2x kasi yan yung nakuha natin na derivative ng given natin na arc. Take note, ay abukuan nyo sa derivative na subuso given na arc. Okay, quantity squared. So, we have 1 plus 4x squared dx. Hence, okay, si 2 pi constant. Okay, si x is x pa rin yan. Bakit yan x? Kasi di ba ang axis of revolution natin class is andito siya, no? So, y-axis. Okay. So, kailangan yung r daw natin is hindi, yung arc natin is hindi siya mag-touch doon. Kasi di ba ito yung arc natin. Kasi yan yung arc. Okay. So, kailangan hindi siya mag-touch sa axis of revolution. Na-mention ko din doon sa previous slide na yung r na yun is the units from the axis of revolution to the one of the endpoint of the arc. So, let's say, ito yung gagamitin natin na arc. So, kung ano natin dito, kunin natin yung distance niya. Okay, if we construct a line here, parang yung sa shell method lang class. Okay, mag-construct tayo ng line from the axis of revolution to the endpoint of the arc. So, di ba ang mabubuo natin dito na r is parallel siya sa y-axis, which means y yung magiging r natin dito. Okay, katulad din ng sa previous slide, ang mabubuo nyo doon na r is y, equals to y. So, ibig sabihin si x, always pa rin yung x. If it is revolve about the y-axis. And then, ds natin is, eto siya, square root of, eto galing dito, 1 plus 4x squared dx. Solving for this, okay, using this substitution, so we let u is equal to 1 plus 4x squared, and then d over 8 is equal to x dx. Okay, we have, si eto, nire-write ko lang, nilagay ko dito sa last si x, para ito maging square root of u kasi gilat natin na is yung radicand natin. And then si x dx, that is equivalent to d over 8. So, integrating this one, we get 1 over 12 times 1 plus 4x squared raised to the power of 3 halves plus c. So, substituting it to the previous equation, ito. Okay, so we get, yung area natin dito class is magiging pi over 6. Okay, so si 2 pi ha, constant yan. So ito, ang equivalent na to, yung na-solve natin using the substitution is ito siya. So we have 1 over 12 plus 4x squared raised to the power 3 halves evaluated from 0 to 2. Okay, so we get pi over 6 times 7 square root of 17 minus 1 square root square units rather. So this is the area of the surface of revolution. For the last example sa area of a surface of revolution, ang given natin na arc dito class is in parametric equation. Doon kasi sa previous two examples is, ang given natin na arc is just a function. So here, ang given is a parametric. So find the surface area generated by revolving about the x-axis pa rin. So the arc given by C equals to the set containing xy such that x is equal to t cubed and y equals to 3 halves t squared, where t is evaluated from 1 to 3. So we use this formula. Okay, so ito yung formula 2, di ba? And then iba yung, depende kung saan nag-revolve yung, solid natin. So here, ito yung ginamit natin na formula 2, letter A. Okay, so where y of t, yung y of t natin, yan yung sa given natin na arc, y is equal to 3 halves t squared, and then x of x natin is equal to t cubed. So, ibig sabihin, kunin natin yung derivative na to. Ang derivative nito class is 3t squared, di ba? And then derivative ni 3 halves t squared is 3t. Okay. Ibig sabihin nun, kunin natin yung derivative ni parametric equation in terms of x and then parametric equation in terms of y para masubstitute natin dito sa formula. Okay. So, si 2 pi, constant yan. Si y of t, okay, yan yung, eto, ang gagamitin natin is yung y in terms of t. That is 3 halves t squared. Tapos, ito siya. Okay, si y of t class, kinuha yan dito sa given natin na arc. Kung x of t naman, ang gagamitin ninyo is yung parametric equation in terms of t. And then si dx over dt, yan yung derivative ng, ito, yung derivative niya, yung sa x. Okay, so 3t squared. And then dy over dt class, yan yung derivative ng y natin. So that is equal to 3t quantity squared and then dt. So 2 pi integral of 3 over 2t squared, square root of, okay, 90 to the power of 4 plus 90 squared dt. Okay, so simplify natin class. So diba 2 pi times 3 halves magiging 3 pi times the integral of t squared, square root of 90 to the power 4 plus 90 squared dt evaluated from 1 to 3. So, itong nasa loob natin class ng radical or the radicand rather, pwede natin siyang ma-factor as 90 squared times t squared plus 1. So, ang square root ni 90 squared class is 3t. Diba? We left with t squared plus 1 na lang sa loob ng radical sign natin. So, 3 times 3, that is 9 pi. Okay? And then, si t squared times t is t cubed na yan. Square root of t squared plus 1 dt. And then, si t cubed plus, pinactor ko siya as t squared times t. Para ma-integrate natin siya using substitution and then letting this one as our u. So, let u is equal to t squared plus 1. Itong nasa loob. And then, du, ang derivative ni t squared plus 1 is 2t. Or du over 2 is equal to t dt. So, we have, okay, here, nilagay ko lang to dito. So, 9 pi times the integral of u minus 1. Okay, di ba itong si t squared class is solving for t squared here. Transpose natin si 1 dito. So, we get u minus 1, di ba? And then, yung nasa loob ng radical sign is yan yung gilat natin u. So, that's why square root of u. And then, t dt is yan yung du. So, we obtain by simplifying class, The square root of 9 pi over 2 times 100 over 3 square root of 10 minus 4 over 15 square root of 2 square units. So that is for the area of a surface of revolution. Just familiarize the formulas na na-discuss ko sa first slide.